This is the screencast for section 6.4, example 5. We're going to learn how to convert the equations of polar functions into rectangular, or what you call function mode, and vice versa between examples 5 and example 6. So first I want to show you the example that the book gives and kind of give you a graphical comparison of what polar functions do compared to rectangular functions. So if we look at the graph of r equals 4 cosine theta, if you remember in example 1, I showed you that demonstration of 3 cosine theta. Well, this is kind of the same thing. We're looking at 4 cosine theta, and we'll show you why. I said I was going to show you why that makes the graph of a circle. So I'll take r equals 4 cosine theta, which is in polar coordinates or polar graph, and I'm going to multiply both sides by r. So on the left I get r squared, and on the right I get 4r cosine theta. So if you remember from our study of extraneous solutions, when you create an extra variable by squaring both sides, or in this case multiplying both sides by the variable, you get more outputs than maybe originally. So that's going to lead into why we have a non-function as our end result, a full circle as opposed to a half circle. But anyway, keep going. So the next step, r squared is x squared plus y squared, and we know that because if we look back at example 3, when we were trying to find the x and y coordinates of polar functions into rectangular mode, or rectangular functions, we set up the Pythagorean theorem. So x squared plus y squared equals r squared just by Pythagorean theorem. So if you multiply everything out on the left side and then factor our x squared minus 4x plus 4 into x minus 2 squared, you get a circle with center 2, 0. The 2 is being subtracted from x, 0 from y, and then radius 2, which we would have to graph in our calculator as y equals the positive square root and then the negative square root. So we'd have to graph it in 2 different y functions. So what I did was I put the rectangular or function mode up here at the top, and you can kind of see some of the x and y values that go along with those 2 functions that make up the circle. Or in polar mode, there is one function, 4 cosine theta, and I set it from 0 to pi, because as we saw in example 1, it only takes pi radians to get the full circle, because the r value after pi over 2 radians would be negative. And you can see that after pi over 2 radians we get negative r values, which will put the points in quadrant 4. And then I showed you some of the points that are associated with the same points up at the top here. Now, your calculator, you have an option for the calculator to show you theta and then the rectangular coordinates, or theta and then the r value. So you get to choose that in second format or second zoom. This top selection here, you can choose to rectangulars or polar coordinates. So you can kind of check your work from the previous examples with that option as well. So as we saw in that example, our goal is to kind of create an expression of including r cosine theta and or r sine theta to substitute in x and y, so we get a function of y in terms of x, etc. So let's look at the example 5. It says convert r equals 4 secant theta to rectangular form and identify the graph. Support your answer with a polar graphing utility. So we want to graph in polar mode. My goal is to get an expression of r sine theta or r cosine theta. Well, I have r, and then on the right hand I have 4 times 1 over cosine of theta. So let's just multiply both sides by cosine of theta. And then in that one step, I have r cosine theta now on the left side, which equals 4. So r cosine theta was our x coordinate, so x equals 4. So this should be a vertical line, x equals 4. So I graphed in polar mode 4 over cosine theta, which is 4 secant theta, and I can see that I have a vertical line here at x equals 4. So my answer is correct and supported with a polar graphing utility. I wouldn't be able to graph vertical lines in function mode anyway. Then now try problem number 35. Same kind of concept. As a matter of fact, it's going to be the same exact situation, which is why I showed you the previous example. But I'll take r equals 3 times 1 over cosine theta and multiply by cosine theta for each side. So on the left I have an expression r cosine theta that can be substituted in for x, and then that would equal 3, so I have a vertical line, x equals 3. And using the same window I used last time, I graphed 3 over cosine theta, and there it is, a vertical line at x equals 3.